When we are back, and we are going to be doing our problem set 4 solution videos. So we have 3 systems. I'm going to get into Mathematica here. I'm going to quit my kernel as well. So we have system A. Number of A is equal to 12. X of A is equal to 15. S of A is equal to 3. Number of B is equal to 98. X of B is equal to 17. S of B is equal to 0.5. And number of C is equal to 22. X of C is equal to 19. And S of C is equal to 8. So we need to calculate our 90, 99, 95% confidence intervals, all that good stuff. So what we're going to do is we're going to open up our notebook. We're going to open up our notebook for file. We're going to do our lecture 5. So let's go ahead and shift this over here. Let's shift this over. So we need to find our t values. So our t of 95, is it 90, 95? So 90, so that's 0.1 divided by 2, so 0.5. And then our number, ooh, that's not, let's go look back. A was measured 12 times. So T05, 11. So 05, 11, that's going to be 2.201. T025, 11 will be, or actually, excuse me, 0.05 should be 1.796. 1.796, 2.201, and then 95 should be 005, that should be 3.106. T of 005, 11 equals 3.106. Great. Okay, so those are my 3 t values for system A. So all I have to do to find my confidence interval is going to be x of A plus T05, 11 times S of A divided by square root of N of A. There we go. And then we'll do a minus as well. And then all we have to do, we'll copy and paste that. And then we'll do TO25. Then we'll get that, and then we'll do this here and go to 005. All right. And we can shift enter all of those good things. Great. Now we're going to do the same thing, but for B. And let's go ahead and do that right now. So for B, we're looking at 98 measurements. So that'll be T infinity. So we're going to do T infinite, basically, actually, T05 inf equals, so we're looking at 1.645. Then T025 inf equals 1.96. And then T005 inf equals 2.576. So we'll do the same thing. Actually, let's go ahead. XB plus T05 inf times S of B divided by square root of NB. And then we'll do that plus minus, do all those good things. Minus, and Control C, 025, 005, 005, and then we got this. Great, and then finally, we have 21. So T05, 21, that's going to be equal to 1.721. TO25 21 equals 2.080, and then TO0521 equals 2.831. Great. X of C plus T025 11 or 21. Be careful. Times S of C divided by square root of NC. And then copy and paste that. Get the minus, and then copy and paste the pair. Then we can start to move. Boom, boom. 05, 05, 225, and then 05. All right. There you go. Fantastic. So, what is the problem asking? We did the confidence intervals. Now, let's look for the data files, and we're going to calculate that too. So, let's go to our R code. I'm going to control enter these. I'm going to go to and set my working directory. And I'm going to set that as this. It's going to be my working directory. I'm going to set that working directory as such. And then I'm going to set that in here. So that's my working directory. So I'm going to go this. And now I'm going to read in these data files. I'm going to take a quick look. Ooh. I may need to do a quick edit of those data files. So actually, so let me actually add. Let me insert. Let's insert that there. Yes, I do. Yep, I'm going to do the same thing. I'm going to do the same thing for those other files. Just because I don't want to lose that first. Again, we need column headers. But it's a good, honestly, it's a good, good little check to make sure that we don't miss that first data set. All right, now let's save it. Then now let's now let's take a peek. No. Good. So we're going to actually take, and we're not going to look at the second column because there's only one column. So we'll look at the first column, and then we'll get our confidence intervals. Oops. There we go. So here we go. Oh, let me do that. Confidence interval. Next data set. Bit larger. And then finally, the last data set, very tight. And there we go. That's it. So we will see you all next time on Problem Set 5. See you then. Thanks. Bye.